doctoral researcher in Mega University. Today, I'd like to talk about the evaluation and visualization of multiaxial traffic behavior and random non-proportional loading condition. This is background. Some material and some structure received undergo the multiaxial loading and non-proportional loading. For example, this junction piping receives non-proportional loading due to temperature fluctuation caused by mix with hot water and cold water. So in order to have a guarantee for safety and soundness of structural components, appropriate understanding and damage evaluation and non-proportional multiaxial loading are strongly required. So first I explain the non-proportional loading. Non-proportional loading is multiaxial loading in which direction principal stress and strain are changed in a cycle. And like this one. And this loading it is very hard to define the stress strain length. This epsilon and gamma coordinates, this loading is non-proportional loading. So what is the strain length? This one or this one, this one. It's very hard to define. And under the non-proportional loading, and this additional hardening caused by dislocation interaction. And failure life under non-proportional loading is reduced depending on loading path and material constants. So our laboratory presents this IS method. And this method is a simple method of determining the stress and strains. For example, this very complex loading path. This complex loading path can be changed this unique stress path and waveform. And in this method, failure life and non-proportional random loading strain path can be evaluated. And so in this presentation, firstly, I explained this IS method. In addition, a method of visually presenting the principal stress and strain to assist design to understand the loading mode and the 3D used program is present. First, I explain the IS method. So first, we use this XY coordinate. This XY coordinate is arbitrary coordinates. And this S1T, S2T, S3T are maximum and middle and minimum principal stress strain vectors. So firstly, we calculate the principal stress strain value at the arbitrary. For example, this SIT is value of principal stress strain. It's calculated in this equation. And after we get the maximum value of SIT using this equation. So this value is most maximum absolute value at the time t, and this one is maximum absolute value of principal stress in a cycle. So we use this maximum value of direction of maximum value of SI max is used for reference axis like this one. And next use this x, y, and z coordinates. So this x, y coordinate is used for calculation of direction variation. This direction variation of SIT is calculated by this cosine t and theta t. And the cosine t and theta t is calculated by this equation. This E3 and EY is unit vector of the y-axis and z-axis. So third step, and we use this polar coordinate. So this direction of the loading is used this zeta cosine t and theta t. And this magnitude of the loading is used this already calculated this principal stress strain value. And this magnitude is can be used mid stress is okay. And this loading path projected this reference axis. So we can obtain the we can obtain this loading waveform, and this loading path is projected to this SI3 axis. So we can obtain the non-proportionality. This non-proportionality is a degree of the change of direction of principal stress strain. And this non-proportionality F and P is calculated by this equation. This non-proportionality is meaning of integrate of this loading path. And our laboratory presents this strain parameter for evaluate the non-proportional loading, like this equation. This delta epsilon I is used this delta SI, so load and strain range. And this FNP is non-proportionality. This alpha is a material constant. This material constant is material dependence of life under non-proportional loading. It can evaluate by this stress strain curve. This is a stress strain curve of push-pull loading. This test is proportional loading test. This stress strain curve circle test, and this circle test is a non-proportional loading. So we use this difference. This difference is material constant. So this is the meaning of the additional hardening due to non-proportional loading. So we carried out several loading paths and evaluated the failure life. This is evaluated by the IS method. Almost data is plotted on into the factor of 2 bands. So we already checked this method is very suitable parameter for evaluate the failure life under non-proportional loading. And in the presentation, I explained the program for visualization of loading paths. And this program uses this input data. And this line is time, and this line is temperature. And this one is strain condition. This one is x-axis strain, y-axis strain and z-axis strain. And this one is gamma xy, gamma yz, gamma zx. So this data input the program, and the strain waveform of 6 components is displayed. After that, calculated the loading condition, and the loading path is displayed in polar coordinates. After that, calculation, strain waveform and non-proportionality is calculated. And in the program, use three type of method of the reference axis. So one method of the to define the reference axis, direction of maximum strain. This method is already explained. And other reference axis is direction of maximum damage. This reference axis is defined by defined pen, and this loading damage will be a maxima. Sorry. So we use two types of reference axis, and projected the loading path. After we use cycle counting of the rain flow method and evaluate the failure life. And we use other one is data reference axis is a direction of this by user. By user can be defined the reference axis like this. And a designer can be seen the loading path in 3D coordinates. And this is life evaluation under random loading. This is input data. This is loading path in polar coordinates. So it's very easy to understand that this one is proportional loading, this one is non-proportional loading. And evaluated failure life is use this program is 2,257 blocks. This experimental life is 2,500 blocks. Under non-proportional loading, production life is 10 blocks, and experimental life is 7 blocks. So this experimental life, number of experimental life, and number of production life is almost the same. So it is very good parameter for evaluate failure life. This is conclusion. Software to visually indicate the stress and strain states. The non-proportionality of loading and life evaluation was developed based on the IS method. It was applied for the life evaluation under the multiaxial random fatigue loading. The software enabled researchers and engineers with the specialty knowledge on multiaxial fatigue loading to assist fatigue strength and non-proportional multiaxial fatigue combination. Thank you for your attention.